How to model a drum kit with parametric modeling. Start by modeling the basic parts of the drum. You can model them yourself or download the project file. There's a link in the description. Now is time to add parameters and constraints. In the mechanical browser, add 3 new parameters and change their names and expressions. Height 300, rad 150, bolt 6. Now add a coincidence constraint to the bottom face of the drum kit to lock it into position. Choose the world option, choose the origin option, select the bottom face of the drum shell. The face of the drum shell is now fixed in position. Now we need to convert the skin, rim and bolt into components. First set the constraints, then convert each into a component. Set a radius constraint to the outer face of the drum skin. Change the expression to rad. The drum skin radius is now the same value as the rad parameter. Test this. Right-click the rad parameter and select Animate. Use BM Form to convert the skin into a component. Select External Component and set the origin point as the center of the top face. Give it a sensible name and storage location. Once you have created the component, it will appear in the mechanical browser. Right-click the rad constraint and select Link to Parameter. Test the constraint now. Right-click the rad parameter and select Animate. Repeat these steps to add radius constraints to the ring and change the values. Set the origin point to the center of the ring. Copy and mirror the bolt. Add a distance constraint between the two faces. Set the distance to height minus 112. Test it. Right-click the height parameter and select Animate. The first face you set will be the stationary face. The second face will move relative to the location of the first face. Use BM Form to convert the bolts into a component. Again, use the external option. Set the origin point to the center of the washer on the bolt. This should be the bolt that does not move when the height parameter is animated. Right-click the height constraint. Select Link to Parameter. Copy and mirror the skin and the ring. Right-click the height constraint, select Link to Parameter. Mirror, copy the skin and the ring. Add a coincidence constraint to fix the bottom drum skin in place. Choose the world option and choose the origin option. Select the top face of the bottom skin. Fixing components relative to the world coordinate system makes their behavior more predictable and prevents them from jumping around. Select a coincidence constraint between the inner of the bottom ring and the bottom face of the drum skin. Add a distance constraint between the top and bottom faces of the shell. Set the distance to height. Add a distance constraint between the top face of the bottom skin and the bottom face of the top skin. Set the distance to height. Add a distance constraint between the top face of the bottom ring and the bottom face of the top ring. Set the distance to height minus 6. So far so good. Let's check and see how everything is looking. Right-click the height parameter and select Animate. If you animate the rad parameter, you'll see that the shell does not move with the rest of the model. So let's fix that. Add two radius constraints to the inner and outer faces of the shell. Set the inner radius expression to rad minus 7.5. Set the outer radius expression to rad. Now all that's left is to add the bolt. Move the bolts into position relative to the bottom ring. You'll notice that there's a problem. The ring isn't large enough. Luckily, this is an easy fix. In the mechanical browser, right-click on the ring and select Open from the drop-down menu. The component will open in a separate drawing. Change the expression of the largest radius from rad plus 20 to rad plus 30. Save the drawing. Open the main drawing back up. In the mechanical browser, right-click on the ring and select Update from the drop-down menu. Both rings will automatically update. Use Array Polar. Select the bolt component as the entities to array and use 0, 0, 0, the origin point. In the mechanical browser, change the parameters to radius, rad plus 15. Items, bolts, angle between items, 360 divided by bolt. You now have a way to quickly create drums of different sizes. Typically, drums come in just a few standard sizes. This is where design tables can be useful. I created this design sheet for my drum kit. All I needed was a simple spreadsheet software package. I then saved the table to a .csv. To load a design table into BricsCAD is easy. Enter Design Table. Choose the From File option. And there you have it, your first parametric model. Just add some hardware and a few symbols and you're rocking. Thanks for watching.